Alright guys, so as promised, here's a pre-recorded version of the lecture that you guys are going to be getting today in class. That said, there were a couple different uh, sessions of the class, and obviously I won't be talking to all of you. So feel free to pass this around. I claim no specific rights to it, so as you can see on YouTube, uh, this is free to the public and anybody who wants to view it. So hopefully it's a little helpful. Um, what we're going to be getting into is static actions and events, and statics, actions, and events. Um, so these concepts are super important as you progress through your programming journey. Um, we can, when you first start in Unity, at least how I first started in Unity, I did a lot of direct references. So, for example, I would have like a public game object and drag it into the inspector, or I would have a whole bunch of variables like integers and floats to be keeping track that I would edit in the inspector and have stuck on a game object that I would be able to access, let other game objects access by having a direct reference to that game object. Let's say, for example, I had a cube, right, that just was like a holder for a bunch of variables. And that is an awesome way to start learning Unity. There's nothing wrong with that even in the um, long run. Like, you'll use things like that all the time. Maybe not like a cube, but, for example, if I have a game manager that has a bunch of variables, I might have that floating around in my scene or something like that. I just realized because I heard my dog in the background. This is not being recorded in an official like recording booth or anything like that. So if you hear my dog walking around in the background barking, I'll try and mute my mic if she starts barking and get her to calm down. But I just wanted you guys to be aware of that. So I apologize if we have any interruptions, and or I'll try and cut them out. So yeah, let's get into it. How are we going to actually demonstrate that? I brought up the cube example because we will be using cubes quite a bit. Unity is that's the default. Everybody knows the Unity cube. Um, so we'll be getting into some examples of static variables, static functions, actions, events, delegates, all that stuff. Just with cubes. We're not going to be building a game. We're not going to be building a player control or anything like that. I want you guys to get these core concepts down and think about how can you use them in your current projects, because a big thing, at least for me, a lot of the time I'll code something very hard coding, very dependent on each other, like items are dependent on each other, and then take a step back, maybe even go work on something else for a little bit, and then come back to my code and be like, all right, with a fresh set of eyes, how can I decouple this? At least while you're learning, at least while you're like figuring out how to code, how to build app and game architecture. That's a really powerful exercise for you guys to go through, is retrospection on your code. Um, so we're going to start at direct references, going over a couple things we already know, and then getting into some new stuff. So on that note, let's get into what we already know. We know the Unity Inspector. Unity Inspector is, to me, I've worked in a little bit in Unreal, I've worked in Xcode, I've worked in Android Studio. They all have some kind of inspector, but Unity is just chef's kiss. It takes the cake. It is just, in my opinion, the best one out of all of them because it's clean, it's concise, it's modular. You can understand what you're adding. Like, I have my orange cube selected here, right? And I can see right off the bat, even with everything collapsed, I have a transform, I have a mesh renderer, I have a box collider, and I have this script that I wrote, the cube non-static variable, with a variable called my number with the value assigned to be 500. It's all right there, right in front of you. And it is something that is awesome when you're learning how to make games. And when you're, even when you're already know how to make games and you're starting, your career and working in Unity day to day. The thing is, though, inspectors can get really nasty looking. Unity gives you all kinds of tools and they give you all kinds of um, options for your inspector, but you can have scripts that have scroll bars that just scroll on and on and on, and those are the times that you never really want to get into those positions. To be honest with you, the more you can clean your inspector up, the better your app is going to run, and the more useful the things that are in there will be to your non-programmer. So for example, let's say my cube non-static variable here, let's say this had like 100 variables in it because the cube does all these kind of crazy things, right? If I give that to a designer, and let's say there's 100 variables, 80 of them never really change, or 80 of them every cube interacts with or uses the same value, and then a designer goes and changes some of them, well, then they're going to get unexpected results. You want to keep your inspector as simple as you can for your non-programmer coworkers. Now, a tool in our toolbox that we can use is statics. Now, again, this is a lecture that I'm actually giving you guys in class, so this is where we would be talking about, like, what does statics mean, okay? You can think of, like, static electricity, static energy, there's all kinds of statics, right? But when we're talking about statics in Unity, there are two types, okay? The first one is completely code irrelevant, all right? It doesn't touch code. It doesn't do anything with code. It is just something that Unity gives you. And I want you guys to be aware of this so we know how to use both, and we know how, when we're talking about code statics, that we're not talking about this one. But this one is very important. It's going to save your guys' apps a lot of performance, I feel like. Unity describes statics as if a game object does not move at runtime, it is known as a static game object. If a game object does move at runtime, it is known as a dynamic game object. And the reason that we make this distinguishes is the second part of this definition. It's that many systems in Unity can pre-compute information about static game objects in the editor. Because the game objects do not move, the results of these calculations are still valid at runtime. So I'm going to go ahead and bring up Unity, and I'm going to show you. Sorry, I got a lot of tabs open. There we go. All right. I'm going to close my uncensored game view. It's horrible. We have two cubes here, right? Let me go to make sure I'm in the right scene. Yes. We have two cubes here. All right. I'm going to uncheck this. Every game object that you click on will have a static checkbox up here, okay? And this static checkbox is super important because, like we said in the definition, if your object isn't going to move, you're going to want that checked. And it's going to enforce that because if I go ahead and click play here, I can't move my now checked red cube. And just to give like an example of what the definition is saying, it's saying that there are systems in Unity that are always running. You can think of like how your update function is always running, right? There's lighting systems, there's garbage collection systems, there's all kinds of things. If we click on this little drop down, we can see there's occluders running, there's material batching running, there's AI navigation stuff running all the time. It doesn't stop. And if something is static, that means that they can ignore it, or they can do a calculation with it once, and because it's static, it's never going to change. They don't have to keep doing it. For example, let's say I had real-time lighting in this scene, okay? And these cubes were on the floor. The space underneath the cube, the red cube, that doesn't see any light, that the user is never going to see, doesn't have to have its light calculated. If this wasn't static, well, the computer's going to check every frame. Does the light need to be calculated here? Does the light need to be calculated here? Since you said static, that the thing on top of it is static, checks it once and says, all right, I know it's never going to need to be calculated, so I don't have to do that math. All right, so you're saving, especially when you're working on mobile devices, you're saving a lot of resources. In addition to that, another really important one here is this batching static. If I had 10 red cubes here, Unity could, if I remember correctly, I'm not really a graphics guy, but if I remember correctly, it's going to take the materials of that and try and render them all individually, even though they're using the same material. Whereas if you have batching static on there, it can pool and look at like, okay, it's using the red material. And that can then be used across the board, right? Anything else that's checked batching static and using anything, sorry, got sidetracked by a notification from my job. Batching static, if that's checked, will be, close this so they can stop. Will batch, put into groups all the materials that are duplicates basically. So instead of rendering or calculating material uh, like procedures and calculations and all that stuff for all the red materials 10 times, once for each cube, you might get 1 or 2 times. I'm going to go ahead and quit that so that maybe now we won't get any more interruptions. Sorry about that, guys. Now, if I were to go unplay, I want to go into the other part of statics. Where did my PowerPoint go? Now, statics and code. All right, this is really the meat of what I want this presentation to be about. If we read from what Microsoft Docs say, and Microsoft Docs, it takes, if you read Microsoft Docs and actually look at the definitions and are like, man, this doesn't make sense, take a breath. They are hard to understand because they use a lot of computer science jargon. So I want to break this down for us so that we can get through it. They say use the static modifier to declare a static member. Personally, I think you should never use the word you're defining in the definition, in the word's definition. So that part, okay. You can use the word static to make a static variable or function or whatever you're going to make. The next part's important though. It says, which belongs to the type itself rather than to a specific object. Okay. Now, what does that mean? Because that is the real meat of what we're getting into. We're going to start with static variables, but I think what we should do first is just start with variables. Right? We know what they are. I know you guys have already went over this, but I just want to touch on it. Let me take a sip of water real quick. And the variable that we're going to be like using as our example is this my number. I'm going to go ahead and bring up Visual Studio, and I have two scripts in here. Okay, I have public int my number. Cube non-static variable is the class, and we can see that the red cube has one of these, the orange cube has one of these. Red cube, my number is 300, orange cube, my number is 500. Okay, with me so far? All right. I also have another class in here called number printer, and it has a reference to the red cube. If I click on it, you see it highlighted over here, and I have orange cube. If I click on it, you see it highlighted over here. Number printer, every frame, because remember, update goes every frame, so if you're running 600 frames a second, this is going to happen 600 times a second. It's going to print out red cube and then get red cube's number. And the same thing with orange cube. It's going to print out, it's going to say orange cube and then print out orange cube's number. If I go over here and I hit play, this is the part we didn't look at last time, we'll see, yo, it's printing, and it's just going to keep printing and keep printing. Now, there's a danger with how we're doing this, though, because imagine that these were enemies, right? And you were playing like Doom or something like that, right? And they were printing out their health. Just take an example like that. When Doom guy, squishes a demon, you start getting null references because we relied too much on our inspector here. You can see now the orange cube's gone. It's missing its game object. Now, there are lots of ways that you can handle this in a big, complex game like Doom, right? You can have an object pooling system where the enemy never actually gets destroyed. It just gets recycled and turned into a different enemy. You can have all kinds of things. But in this example, this happens more often than you would think. Null references are one of like the biggest errors that you're going to see in your coding career. And missing reference exceptions, all that stuff, they're kind of the same thing. Now, if we go back over to if we go to our next scene, because this is, I just wanted to get a bare bones, like, floor of understanding for us with the dangers of having hard-coded references like that. I'm going to go to this scene. Let me close these scripts and open up our next two. They're kind of the same deal. They're named differently, but they kind of do the same thing. We have red cube and we have orange cube. Okay. They still have a differently named script, but a script called cube static variable with a non-static number here. Just they own a number, 200 and not over 9,000. And then we have our updater, just like how we had that number printer in the last one, except this one's called update static int. Okay. I'm going to open these two guys up. And let's just first take a look at what the cube's got. We see, yes, we have our number. All right, and we know on update here, we're going to be printing out information about our non-static number and our static number. Okay, we have two integers here. We'll ignore the static word for right now. We can just say my static number, my non-static number. The two integers, two numbers. Makes sense. And then what we're going to say, let me pause there and let's go back over to Unity. We'll look at the static word now. If we go back over to Unity, we'll see we have two numbers there, but we only have one number in here. And that's a little confusing, right? Because usually when you make a public variable in our scripts, it shows up in the inspector. Static variables do not. Okay. And the reason for that is we can look here and we can see red cube. You could think of all your variables in the inspector as red cube went to the cube static variable class and made a copy of it. And they own a version of my non-static number. And same thing with orange. It went and made a copy of cube static variable. That's essentially what you're doing. You're making an instance or a copy of a script when you put it on the game object. And it's got its own version of the number that it owns, that it controls, that you could set it to whatever you want. When you have a static variable, the object doesn't own it. That's kind of how you have to understand this. The class owns it. The script owns it. So because this isn't the original script, they're copies of it. They're instances of it. The script down here does own it. Now you can't edit it here either, all right? That's just not something that Unity lets you do. It's just it might sound limiting, but it's really safeguarding you from making mistakes. But the class itself, think of the classes as their own objects, or their own data containers. They own the myStatic number. So let's go over to our updater, and that might make it, or I'll hit play and we can look at what's actually happening here. So we'll see our non-static number is constantly printing out, right? For both of them. That's the number that we wrote in here. And if we scroll down, we can see that red cube and orange cube are constantly printing out their static number, and it's the same. Let's go look at our updater, because our updater, what it's doing is it's making the number different every second. So let's go take a look at that. We're saying, hey, every second, this is a coroutine. I'm somebody who does not like update. I think as you guys go through your programming journey, you'll realize that update is a method that you do not need 9 times out of 10, unless you're doing physics calculations and stuff like that, in which case you'd use fixed update. I personally like running things through coroutines so that you have a tighter control over your code. So on start, once this guy gets instantiated into the scene, I say, hey, start this coroutine, and just have it run forever, unless I tell you not to. We say, hey, class, hey, cube static variable. I know you have that number, that static integer, my static number. And if I delete this and say dot my static number, it pops up right there. I want you to add 1 to it. And then wait for a second and do this again. And then wait for a second and do this again. And we can come back over to Unity and see that it's still printing out and it's constantly updating it, because in our cube static variable class, we're saying, hey, print that out. But the cube doesn't own it. It's essentially going to that cube static variable class and saying, I need to print out this word. I need to print out, or not word, this number. And I know you own it. So what is it? Let me print it out. So hopefully that makes sense. Now, let me go back to the slideshow. Another example, we're going to use my wonderful, wonderful good girls, Vala and Runa, is we could think about this in a real world example. Let's say that we were coding dogs. We were coding puppers. We have a pupper class, and every pupper owns a couple things about themselves. They own their name, they own their size, they own their color, They own their skills. Okay. If we were to say, what don't they own about themselves? Well, they don't own the fact that they were born or they currently have 4 legs. They don't own the fact that they have 2 eyes or 2 ears. That's just something that all puppers have in a perfect world, right? That's just in their DNA to have that. All right. Going back here, we see that these 2 puppers are instances of a pupper, right? They are a unique copy of a dog. So this slide is actually kind of a bad example because these, you wouldn't need a unique copy of it. You wouldn't need a unique copy of the number of legs. You wouldn't need a unique copy of the number of eyes or ears. So really, they can both report to the same base copy and access the static variables of legs, eyes, and ears because they never change. If they do, because there's only one copy, you're still only talking to one object. You know where that, think of evolution static variable of legs, right? If we started as 2 legs and in a million years if humans have 3, well then the static variable will have been edited from an outside source. Just like our updater is constantly editing that one number for the cubes. So you might be asking, okay, how can I use this in my day-to-day? And I encourage you to think about it. How can you use this in your current games, your current projects, to maybe decouple some of your variables so that they're not owned by instances of classes? But a couple ways that I would use it is a shared enemy health pool. Let's say you're doing like an arena shooter, right? And after you've done X amount of damage, the earth shakes or something like that. Well, every time an enemy takes damage, they could then pass over that to a static integer of total damage done, right? Or you could have universal variables that are then reached out for by like vehicles. If all the vehicles in your game do go like 50 miles an hour, well then you don't have to write that on each vehicle. You could just write this is the base speed, or have a base speed and then the vehicles have a modifier to the base speed. And then one that you guys use all the time is time.delta time. That's a static variable that you don't need to have a direct reference to a script for. That's another benefit of this. Because it's not on an object, you don't have to have a reference to an object in order to get it. It just is living in the app, in the ether. Now we're going to take this a step further because I'll be honest, I don't use static variables too much. Static functions take it a notch further on abstracting your code a bit. I'm going to unhit play here. We're going to go to our next scene, which is still our good orange and red cube. And I'm going to close these scripts and open up some new ones for us. Again, same dealio. They're named differently, but they're scripts on the cubes, and we have an updater. Okay. If I open this up, the cubes really haven't changed. All right. We're going to ignore this for right now. We have our update that's going to print out our static number up here. All right. We took away, just for the sake of keeping our code clean, we took away that individual number. So don't think that there's a reason other than that, that public int my number. We really don't need that right now. So I'm just going to take it out because we're past the point of needing to use it for reference. And our updater works pretty much exactly the same. It does start coroutine. It says, hey, I want you to run this coroutine. And every second I want you to, what? What is this? Right? Previously, we had said, hey, script on the cube, I want you to update your static number by 1. Now, as you get further into and more experience with developing code, you'll realize that architecture really, really, really matters. For example, a game I'm working on, our character controller doesn't do much. It has a bunch of services that when the character controller itself just receives inputs. When you move the joystick, it says, yep, joystick's moved. Hey, or joystick service. You hear that? This is how much it's moved by. You go handle that. Or when you hit the jump button, character controller doesn't jump. It says, hey, jump service. Make me jump if I'm supposed to. A button was pushed. Double check that I'm good to go, and then make me do it, right? You shouldn't have all your classes and all your scripts and all your functions should really only focus on doing one thing. All right, and getting as granular as you can there. There are points where you could go overboard, absolutely. And I've towed that line plenty of times and have been told, hey, consolidate this a little bit. And that's okay. It really depends on who you're working with and what makes sense. So building these architectural patterns, there's no right answer, but this is something that I usually like to break it up more and then pull it, make it more condensed if requested by my team, because it's usually easier that way. So for this instance, instead of having our updater actually add one, I'm going to go ahead and say, hey, just tell the cube that it needs to update its number. Tell the cube class update its number. You could think of it like a manager and a shelver at a bookstore, right? The manager isn't going to go put the books on the stores. That's why they hired put the books on the stores. Put the books on the shelves. That's why they hired the the shelver. They're going to say, hey, shelver, please go put these books up on the shelves. So that's what we did here. We said, hey, cube, update your number. And cube will update its number. And the reason we can do this way is because this is a static function. You'll notice I didn't say red cube go update your number or orange cube go update your number. I said the function, the class, the type, if we think back to that definition, go update your number. Okay. So now if we come back over to Unity, we'll see that's now updating its number by 10 every time. Okay. And now one thing I didn't talk about that I knew I was going to forget in the other scene, that's why I put it in here, was if I turn on my yellow cube, we'll see it joins in. And this is another benefit to the static integer, the static variables, is the yellow cube didn't need to know about anything that had happened in the past. It just knows what that number is because it has the same function. It doesn't have to go find it. It doesn't have to do anything. The script here owns the number. So because the yellow cube is tied to this script, it also knows the number. So again, if we go back to like that enemy example, if I have after 5,000 points of damage is done, something happens in the environment. Well, every enemy, or the enemies go into a rage mode. Well, that means every new enemy that spawns can check that damage number and be like, oh man, I gotta go into rage mode. They've already hit this number as soon as they spawn because they have access to it. Let me take another sip of water real quick. Sorry guys, my throat is really dry today. So that's really when you would use functions, static functions. A couple use cases for this is, and some you've already used, input.getKey. You aren't saying, hey, Unity input manager that is at this point in my scene and I've instantiated and initialized and all that stuff, I need you to go do get key. You're just screaming out like, hey, input system, I know you're out there and I know you have a get key function. This is the key code I need you to check to see if it's been clicked. In a bit, we're going to have a change color on our cubes. And you can pass in and we want this to happen to all of our cubes. So you can have the cubes have a static function of change color and pass in the color there. Or just like how we were talking about in that example, the enemy take damage, tell it how much, and then it can report that number up to whatever's tracking the total damage done. But I don't really use static functions. You might be like, man, you don't use a lot of things. Something I forgot to say at the very beginning is this isn't even all the ways that you can use statics. There are so many ways, but this next one is incredibly useful. I use it all the time. And I went too far, sorry. Let's get into it because I think this is going to blow your guys' mind. First thing we're going to get into is our static classes. Same dealio. We have our cube with static int. We have our updater, and actually I believe our updater is exactly the same. Oh, no, it's not. That is a liar. I am a liar. I am a liar. Um, let's look at our. Let me close these. I'm getting confused with what scripts I got open. Open these three. Nice. Okay. This is our cube class, right? It has an update where it's going to print it out. It's got a static variable, and if we go back to the example of the bookstore and the manager and the shelver, right? The bookstore, the manager tells the shelver, hey, put these books on the shelves. The shelver shouldn't have to go carry all the books over to the shelves, right? That's silly. There's probably somebody, in a perfect world, everybody does one task, especially if we're in a coding world. So somebody should have put the books in front of the shelves, and the shelver puts them in alphabetical order or something like that, right? So previously, we had said, all right, the cube can take care of how much it should be adding, but I say no. Everybody does one thing. Whoops. Sorry, had to find which one to close. I say no, should not do that. It should just go to a math system. It doesn't need to know math. It doesn't need to know how to add. It's a simple cube. So what we can do is write something called a utility class. And it doesn't matter that you don't have to name it something, something, something utility, okay? But as you can see here, I have a couple functions in here. I have a multiply function where you add two numbers into it, or an add function where you add one number to it. Let me get rid of that because we don't need that anymore, I think. I am sorry. Yes, we did, but we don't need it to be 10. So you can absolutely just say, hey, I have a class that just takes care of math, or just takes care of inputs, or just takes care of playing sounds, and make that a static class. So that way then it doesn't have to be in the scene. It doesn't have to be anywhere. It's just in your project and accessible by everybody, because everybody might need math, right? They might need to be able to add something. An enemy who's doing like a damage buff when he gets into rage mode might have to go and add stuff, add numbers to its uh, like attack power or whatever. Um, but it shouldn't have to do the math. That should be in a single place. That helps you debug, like, if math starts getting funky. Like, if you had a function in here, like, let's say you had a power-up utility class, right? That just, like, had code for multiple phases of your enemies, like Dragon Ball Z style screaming, right? And they're leveling up and they're getting stronger. They shouldn't need to worry about how much stronger they are, right? You know, Goku screaming in the corner isn't saying, I'm gonna be. Well, I guess they literally did say over 9,000, but they had to have a tool to check that, right? They did. They had a little scouter to check that. Um, they didn't just know that. Um, so moral of the story is your utility classes takes care of mundane tasks that you don't need your other important classes to do. So for example, our cube says, hey, I want you to add something to my number. All right. And if we go to this add, or let's go actually to the source of where this is getting called. Right now we're saying, hey, math utility, the number that we want you to add eventually is just a random number. Let's just keep it random every time we update. Okay. And then the cube is saying, all right, I've been told that I need to add my number to whatever that random number is. And if we go into the add function, we'll see we're going to be adding this to plus how many to add. I don't know why it was 10. It must have been one of the other versions of this lecture that I was doing. So now it's going to constantly add that random number. If we go into here and hit play, I'm going to take another sip of water, we should see the number constantly getting bigger at random rates. Okay. So again, our updater didn't care about the how much was being added. our cube didn't care about how much was being added. The math utility just focused on how much was being added. Okay. So if I go here, that's one way to use static classes. There is a little caveat to it though. Just before I forget, you can't have a non-static variable or function or method in a static class. All right. And the reason for that is because you know how earlier I had said you generally will go through and you'll decouple your code, you'll make it less dependent. This is directly putting a dependency into a class that is supposed to be dependency free. That's what static is. It doesn't belong to any object. This theoretically could be an object, or it is an object. It's and not a game object. I always got those words really confused. It is a C# object. Any kind of variable or class or whatever. I guess this might not be an object. This is just an int, so it's a basic type, right? But having a non-static could be owned by somebody specific, variable, function, method, all that stuff breaks the whole purpose of having a static class. So you cannot, C# won't let you do that in your project. Now, getting over to the way that you can cheat that, because, you know, rules are meant to be broken, let's go over to our next scene. And let me close these guys up. And open up. We're going to get some rave cubes going. We're not going to worry about the events yet. We're going to get that there in a second. And then I just want the color manager. Managers, all right? You have to be careful with managers, okay? They can be super useful if used correctly. Otherwise, they can really mess up your app, all right? You have to use them carefully. The reason, first way you have to use them carefully is what are they referencing, okay? Generally, you do not want them referencing game objects that are in the scene, okay? They should just be resources for your app to go to pull things from. Like, for example, I have this material array. These are the colors that we're going to be having our cubes change to. These are not in the scene. They're in the assets folder. So it's a reference for everything to be able to pick up those materials. If I had an audio manager, I could have it be have references to all my audio files in the project, and then things can pull from that in order to play sound effects. All that stuff. You generally don't want this touching directly things within the scene. We're getting into how to get around direct references in just a second, but the way to make this easily accessible and be able to use non-static variables is to make a static instance of it. You'll remember in our utility class we had public static class math utility. That made it static. It made it so that we can't have non-static variables like this array in our class. But what we can do is say, hey, I want a static version of color manager. You'll see when I have this highlighted, I got some code going on down here with this. I'm going to give you a real world example as to like why. Give you a hypothetical situation, I mean. Let's go back to our Barnes & Noble book. You got your manager, your person putting books in boxes, and your shelver putting books on the shelf. Say the shelver runs into a problem, and they say, well, how many books to a shelf? And they look to their manager, tears in their eyes. And the manager, and they see two managers. Both named instance. Both looked exactly the same, and one says 5 to a shelf, and one says 10 to a shelf. Well, which one do they listen to? You got a doppelganger problem on your hands. The way you solve that in code, because code couldn't handle that. They couldn't go on a interrogation spree and figure out which doppelganger is, or which manager is the real one. The code can't do that. So the managers have to be responsible. You have to have good doppelgangers. And when I say good doppelgangers, I mean ones that will destroy themselves. The way you prevent this situation is by having something called a singleton. We say, hey, if there's a color manager Well, first we ask, is there a color manager calling themselves instance already in the scene? Because you can just go and look for it, because it's not owned by anybody. It's owned by the app. It's floating in the ether. It's a very reliable manager. You could go and say, hey, are you there? When this color manager starts up. If there's nobody there, it says, all right, I guess I'll take the title. I'll be the manager of this app, this Barnes and Nobles. Otherwise, it's going to destroy itself. All right, so if there's already another one, if there's already one there, this got to get gone. I'm going to confuse the app, and we can see that here. If I turn on two color managers, you can see I have different orders. I lied. I do not have different orders. Sorry about that. Let's just move some of these around. I guess I didn't save when I mixed it up. Bam. All right, so we got different orders of materials. So if I said I need the second material and both of these responded, I would get Vala, which is the best material, or I'd get yellow. Okay. Now if I have these both on, what's going to happen is one of them is going to destroy themselves. I don't remember off the top of my head, and I meant to look this up for you guys, which one. I think it's random, honestly, because I'm pretty sure start happens randomly in the inspector. It goes just until all the objects are done. They all shoot off their start method. But one of them destroys themselves. Okay. And that's because we have that singleton method that takes care of that. Oh, that's the wrong. Sorry, I meant to go back to the code. All right. So that's how you have a manager. All right. You generally will want to call it manager. You don't have to, but you should. And then you do a singleton method, and now anything can go, hey, color manager, whose name is instance, I need this material. And you might be looking at, hey, what's this guy down here? We're going to get to that in just a second. Because we're going to wrap up our static classes here. How can they be used? Again, I encourage you to think about how they can be used in your projects. But, for example, I was talking about my character controller earlier and how I architecturally don't have it doing anything. It's a static class. Well, there is a static input class. Sorry about that. That receives all the inputs, that just focuses on, hey, I heard that a joystick was pushed. I'm going to scream to the app that the joystick was pushed, and whoever needs to listen to it is going to take care of that. State machines. Really great. Like, what is the game state in? Is it paused? Is it playing? Are you in combat? Things that you can have multiple game states that then people can check your state, or different scripts can check your state machine and behave responsibly off of that. And then again, utility classes. Other than our little math utility that I wrote that can multiply and add, you have utility classes you use already. MathF, Scene Manager, Input.getKey. All those are static utility classes that you use probably all the time. There are dangers of statics, though. And I'm just going to read this definition for us. Static variables represent a global state, and that is hard to reason and hard to test. If I create a new instance of an object, if I make a new cube, I can reason about its new state with tests. I can do tests on it. I can see, like, hey, cube, what's your number? You know, and check to see what it is. What color are you? If I use code, which is using static variables, it could be in any state. I can't go and say, hey, object, that's definitely there, that's definitely existing right in front of me. What color are you? What number are you? And not only that, anything could be changing it. There is no direct reference from this thing changed this variable on a static class where there is on an object. Something has to be touching it. And you can usually trace back to what is calling it. And so when do you use statics? Again, mostly you can use them in any way. There's no reason not to, as long as you use them responsibly. I use them mostly for the manager utility classes and events, which is the big, like, if you guys take anything away from this, this is going to be a really spicy tool in your toolbox. Common way we use model behaviors, I've talked about this a couple times, having a big ol' inspector with lots of variables, which is fine. Okay, for example, this not too bad, honestly. It's something that we're working on in a project I'm working on, and we have been slowly, like I said, re-cleaning up all that stuff. And this is like our build right here is actually for the designers to be able to go and use different parts on our character. Um, but you can get rid of a lot of references. We've already talked about static variables, functions, and stuff like that. You can get a lot of references gone with actions and events. So let's look at the syntax. I pointed out that one line that I was like, oh, this looks different, right? We know public means anybody can access it. We know static means it doesn't have to be tied to an object. Event, you can think of it as like a yell, right? A yell to the app. It's like, hey, I'm screaming my name, update color event. It's just like how we name any other variable. Action means that this is something called a delegate. Okay, an action is a type of delegate. Delegate is like a step higher. Actions are more useful in my opinion, so we're just going to focus on that. And what a delegate is, and by that, what an action is it means that you can subscribe or say when this method, you can think of it as like a method or a function, is called or screamed out because it's tied to an event, do this thing. Okay. The material here is, if you think of like on trigger enter or on collider enter, how you have those parentheses that say this is what I collided or triggered into. These are the things that you put in those parentheses. These are your parameters. So in this case, I'm going to be screaming out update color event, and I'm going to be telling them what material, what color should they be updating to. So let's go take a look at the code. The last bit we got here. Here's that same line we were just looking at. Here's me getting the random color from that list. And here's me screaming it out. I say, hey, update color event, question mark, which I'll explain in a minute, invoke, which just means, actually this entire part right here I'll explain in a second. We can comment this out actually and just do this. Bam. Same deal. You're literally running it like a function. Update color event. Let me pass in the material I want and scream it out to the app. Now how, if I go ahead and go back to code, or go back to Unity, sorry, and hit play, I'm going to start screaming it out. I'm going to get a null ref. Be like, what the heck? What is going on? This is where I start calling it out. This is where I scream it out. It's because nobody's listening. How would you feel if you were yelling and nobody was listening? Nobody likes being that guy, right? When I come over here, let's pull the code back over. This is the script that I have on my cubes right now. I'm going to comment on a line for us real quick, so I want to break it down for you. We're going to say, hey, when the color manager screams update color event, I want to update my material. And that's all this line is doing. It's saying, hey, that material you screamed at me, I'm going to make my material that. And you make that happen by doing this plus equals. Okay. So update color event gets screamed out. I do it. If we go over here and turn on our cubes that are going to be listening for the scream and hit play, we should see them start changing colors. It's working. It's great. We have rave cubes. Except now, once one gets deleted, once our enemy gets smooshed by Doom Guy, we get a null ref again. And that's because as we saw like it error out when the color manager was like screaming and nobody was listening. Well, now the color manager is screaming and saying, hey, 2 people are listening. They better hear me every time. When you destroy or when you get rid of that orange cube, it needs to peace out. It needs to say, hey, I'm done. I'm not listening anymore. So that the manager doesn't freak out when 2 people aren't hearing it. So if I uncomment that, Go back here. We'll see. Good to go. And I delete it. Now, there are obviously situations where you might be sending out events like this and you don't have anything in the scene. Maybe the enemies spawn in after the manager starts screaming. The way to circumvent all of these issues is this original line that I commented out. If you already know what this question mark does, then this is going to make a lot of sense. But this is called, I believe, I'm really bad with vocabulary, so I'm going to have to double check this and put a little correction if I'm wrong. The ternary operator, I think is what it's called. And what it says is, basically it's like a null check, right? Is anybody listening, yes or no? Right? If so, go forward and scream it out. Invoke that scream. It's like something from Skyrim, right? Like, do the scream. Do the shout. This will check for you that somebody is definitely listening. So if I go back over here and turn these guys off, we're not going to actually spawn them in because we don't need to get into instantiate code. But no errors. We're good to go. As soon as I turn one on, bam, it starts changing. As soon as I turn another one on, bam, it starts changing. We did that peace out code, so if I turn this off, you can see it is not still changing, and the manager's not screaming. If I turn it back on, it starts changing as soon as the next scream goes out. So that's the power of actions and events. You can do so much with this, right? You do not need to have that direct reference to both cubes. You can do this with static variables, or you can do this with events or functions or managers and all that stuff. The power of statics and the powers of events are crazy, and they help clean up your inspector so that your designers and your artists and everybody who's touching Unity doesn't have to wade through all your extra variables. Trust me, my friend Arwen, when we were students, she would be like, this is a mess. Why do you have so many things in the inspector? And I didn't know any better. So this is like a super useful tool for cleaning up your inspector, making your code less dependent on other scripts, and also helping with your performance. Well, that's it, guys. If you have questions in the slides, there should be an email address that please feel free to reach out. And then, yeah, have a great one. Thank you for watching.